Okay, people, this is 3-6. We are going to do up through example 3 today, and then we're going to finish the rest for Monday. Inverse functions. Inverse functions. Here we go. Write this at the top of the paper. We'll talk a little bit about what an inverse function is. Inverses undo one another. Undo one another. Two functions that are inverses of each other undo one another. They have to exist, otherwise we can't solve for things like, let's say, x squared. What's the inverse of x squared? What undoes an x squared? The square root of x. Technically, if we want to be technical, it's positive and negative square root of x, right? Those two things are inverses of each other, okay? A x cubed, how do I get rid of an x cubed? The cubic root, that one doesn't have plus and minus in front of it, okay? Other inverses, like what's the inverse of a linear function? Like just x.
Isn't that when you like plug in the other?
Right, we're gonna do that here in a little bit. What the inverse of a linear function is actually another linear function. It's actually negative x. FYI. Well, no, don't write that down. Just put x, because it's not always negative necessarily, okay? So the inverse of a linear function is another linear function, okay? Let me talk to you about, we're going to talk specifically just over here before we start about x squared. X squared is a parabola. He looks like this, okay? His inverse is positive and negative square root. Do you know what positive and negative square root looks like? Do you know what a square root looks like? If you graph it? It starts here in the middle and it goes like this. Whoop. Okay, so what's the negative one look like? The other way. Whoop. Okay, so it's literally a parabola on its side. Okay? And so every inverse function is a reflection across this magical dotted line right here. It's like I've taken this guy right here and I've flipped him over top to get to over here, right? Like that is always the case, that two functions, when you graph them, they are inverses if they are reflections across this line, which is the line y equals x. Nice. Nice. Y equals x. That's the magical dotted line that they are reflected across. Okay? There you go. Perfect. Okay. Inverses. Inverses undo one another. That's what we want to have happen. Okay? All right? So, graphing an inverse relation. We said that, like, this is a parabola. This is exactly what I just got under graphing. We know that this parabola is going to go on its side, but more specifically, when we plot points, if they are inverses of each other, an xy coordinate will switch around and it will become yx. Okay? That's what happens to the coordinates of an inverse function. X and y switch places with each other. Okay? And that's how we find an inverse actually. So x and y switch places, it becomes y and x. Shh. I'll go longer. Shh. Okay, xy becomes yx. So the point 0, 0. If I flip him, he'll stay 0, 0, right? 1, 1. If I flip him, he'll stay 1, 1. What about negative 1, 1? 1, negative 1. So he'll be right here. What about 2, 4? 4, 2. What about negative 2, 4? 4, negative 2. 3, 9? 9, 3. And negative 3, 9 becomes 9, negative 3. The x and y coordinates just switch places with each other. That's how it works, okay? X and y switch places with each other, okay? Good, good? Happy with that? Okay? That's how that works. And again, it's just reflections across this line, y equals x. When we were in geometry, we learned about transformations across that line, y equals x, and this was literally the rule for it, was that xy became yx. They just switched places with each other, okay? Good, good? All right, now, if you are given a function like this guy right here, this is a linear function, and I say, find the inverse function, okay? I know how to switch coordinates around. I know that all you do for the coordinates is just flip the places of them. But what happens if it's a function? What do I do if I have a rule for a function and I want to find the inverse function, right? I do the 4 steps, and the 4 steps are right here. 4 steps to finding an inverse. The first step is, if it is named something other than y, you're going to change it to be named y, okay? And then the next thing that you do is you take the y coordinate and the x coordinate and you switch places with each other. Oh, kind of like you did up here. You take the x and y and switch places with each other, right? Then what's the third step? What do I do after the y and x are switched places?
Solve for y.
You solve for y. I get the y by itself again because now it's on the on the other side of the equation. So I solve for y, and then that y gets renamed back to f inverse of x. Okay, f inverse kind of looks like f to the -1 power almost. Okay, so really the hardest step is probably step number 3 where you're solving for y. Otherwise, you're just renaming stuff like steps 1, 2, and 4. In fact, most people like in trig and calc. My algebra kids, I make sure like do step 1, then do step 2. But like trig and calc, you guys can do step 1 and 2 at the same time, right? Okay, so like here, if this is a linear function, okay, and I said the inverse of a linear function, what did I say up above? The inverse of a linear function is going to be another linear function. So we can kind of assume that this is going to be another linear function, right? Now, if I do example 1 or step 1, this is going to switch to y, and if I do step 2, then I flip places with each other. So it will look like x equals 3y minus 2, yeah? That's like step 1 and 2 at the same time. I've renamed it y, and I've switched the places with x and y, yeah? Okay, we can handle that, like that's not too challenging. All right, now we go up to solve for y, and what are you going to do first? I'm going to get y by itself. Add the 2 over. Okay, great. So what does that look like? X plus 2 equals 3y. Okay, then what? Divide by 3. Divide by 3. Okay, now I'm going to show you 2 different ways of writing this, okay? Y is by itself now. I'm going to take and I'm going to rewrite that y as f inverse of x, right? Okay, equals, I can leave it as x plus 2 over 3, or I can change it to x over 3 plus 2 over 3, okay? Because technically everything is divided by 3. And really, this means like 1/3 x, right? If I want to shove the x off the top. Now, you're like, why would I do all that work if I could just leave it like this? Like, I would just love to leave it like this. I'm going to tell you that if you're going to graph this linear function, it's probably going to be easier to graph if it's in the second form because you're going to start at 2/3 and then you're going to go up 1 over 3. So if I ask you to graph it afterward, I would suggest doing the second one where you put each thing over top of 3. Does that make sense? But technically this guy is the inverse. Like either one of them is the inverse. They will work. Which one do you like better? You like the second one better? Okay. It's kind of in the mx plus b form, right? Because it's a linear function. Okay, I just said a linear function, his inverse will also be linear. Right? Good? Okay, so however you want to write that, I don't care. Okay, that was the first one. The second one, example 3. This guy is gross. This guy is gross. Can I change this problem just slightly so it's not so gross? Can I get rid of the x on the 4? You're going to want to get rid of the x on the 4. I don't want to do that. Get rid of the x on the 4 because I don't want to, otherwise we have to do the quadratic formula. We don't want to do that. Okay, so get rid of the x on the 4. So pretend that this just says x squared plus 4. We're gonna change the rules because I know on your homework assignment it's not going to give you anything that ugly. So pretend that it says f of x equals x squared plus 4. All right, we want to find the inverse. Step number 1, change it to y. Step number 2, what will step 2 look like?
X equals y squared.
X equals y squared plus 4, and then I have to find the inverse. Oh, by the way, what is this thing? What's the original guy? What is his parent function? What does he look like? He's a parabola. He's a quadratic function. What will his inverse be? What undoes a quadratic function? A square root function. So I know that eventually I'm going to get to a function that's a square root. All right, so I want to solve for y here, and first, minus 4, perfect, okay? So I have x minus 4 equals y squared, and then what? Take the square root. So, what will he look like?
Plus minus square root of x.
Plus minus, don't forget, the square root of x minus 4. And I'm going to call him f inverse of x, yeah? Plus minus square root of 4. Now, you have to make sure that when we put the square root in, you do the plus and the minus because the plus gives you the top loop, the bottom gives you the bottom loop. Otherwise, that won't be a quadratic function anymore. It won't be a parabola anymore on its side if you only do the top, the plus. Right, Jake?
Huh?
Right, Jake?
Yeah.
Right, Jake?
Oh yeah, I failed that on my
Oh yeah, he failed that on his test. All right. Anyway, okay, happy with that? Those are the 4 rules.
Just like physics.
Boom.
Okay.
Boom.
We done?
Can I do one more thing real quick? Real
No.
quick, off to the side over here because it has to do with example 2. Off to the side over here, and I want to do it because we just got done talking about this, okay? All right, here's the deal. I want to, okay, we have our two functions. We said that our two functions were y equals 3x minus 2, and we have our inverse function is y equals x plus 2 over 3. Okay, this is going to be really hugely important, and I want to do it today because we just got done talking about this. Those are my two functions, and we found that as the inverse, right? Here's the deal, okay? We'll call this, let's call this function f, and let's call this function g, even though this is technically f inverse. We'll call that f, and let's call that g, okay? Good? All right, off to the side over here. Here's what we're going to do. We're going to do f composed of g really fast, and then later on down, we're going to do g composed of f really fast, okay? F composed of g, g composed of f, okay? When we do f composed of g, which one goes in the inside? G goes into f. Okay, so this guy is going inside of there. So I have 3 parentheses. X plus 2 over 3 minus 2. Okay, simplify. What can we simplify there?
Actually,
The 3 goes away. The 3's can cancel, right? And I have x plus 2 minus 2 equals x equals x. Oh man, we saw this on our homework assignment for the last section. Now we're going to do g composed of f, okay? G composed of f means I'm taking the f and now I'm shoving this into the function. So it is x plus 2 over 3, but instead it's going to go 3x minus 2, like that. The parentheses aren't doing anything, we just said. So the minus 2's cancel. Minus 2 and plus 2 cancels. And then I have 3x over 3 equals x. Okay, now, do you know what that means? If you stick one inside of the other, and then vice versa, you stick it inside of the other, and both of them come out to be x, that means that they are inverses of each other. That means they're inverses of each other. Why does it come out to be x? And why not like 0? Why doesn't everything cancel? They're reflections of each other across the line y equals x. Yeah? So when you compose them, when you stick one inside of the other, everything gets rid of, everything goes away except this line y equals x right here. Okay? So on your homework assignment that we just did, let me make you dizzy. Boop, 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 boop. I gotta find it. Hold on. Un momento, por favor. Right here, where it said, verify that f composed of g of x equals x and g composed of f of x equals x. What does that tell you about this function versus this function? They are inverses. Same thing here. This function versus this function, they were inverses. They were like leading you into this section, right? Okay? All right, we'll talk more about that on Monday. There you go. Okay? Happy with that?
Yeah.
Woo! That was like way ahead of time.
Can I call
Very
Andre
nice.
real quick for me?
All right, goodbye people on this video.